Okay, we're going to do January 2010 Ph04 questions 1 to 3, the first 3 multiple choice questions. Right, so on this first one, a particle completes, there we go, 6 revolutions in 4 seconds, and the angular velocity in radians per second is. Okay, so to work this out, I'd put the equation for angular velocity, which is the angle in radians over the time it takes. Now remembering that 1 revolution is 2 pi radians, so that's 6 revolutions there. So 6 times 2 pi is going to give me 12 pi, all divided by the time. Well, it's doing those revolutions in 4 seconds. So if I cancel that down, 12 divided by 4 is going to give me 3 pi, and if pi is just over 3, so 3 times 3, it's going to be 9 point something. So I would say that there's your answer there, B, 9.4. Moving on to 2. Which of the following is equivalent to the unit for energy? Well, as you know, the unit for energy is the joule. And so I just need a suitable, probably GCSE equation for translating that down into its base units. So in my mind, I've got the equation for kinetic energy equals a half mv squared. Now clearly the half has no units, but the unit of mass is a base unit, it's the kilogram. The unit of velocity is the meter per second, and if you square that you get the meter squared, and seconds squared, or seconds to the minus 1 squared is seconds to the minus 2. So there we have the correct answer is A. Now moving on to the last one. A radium nucleus decays by emitting an alpha particle. Okay, an alpha particle, fine. The speed of the recoiling nucleus is small compared to the speed of the alpha particle. Okay. This is because the force acting on the recoiling nucleus is smaller than the force acting on the alpha particle. That can't be true because of Newton's third law. The momentum is mainly concentrated in the alpha particle. Again, that can't be true because the momentum of both the alpha particle and the recoiling nucleus must be the same, so that discounts B and C. So if they've got the same momentum, the only thing that can be correct is D, because they've both got the same momentum, but because the nucleus has a much larger mass than the alpha particle, it's going to end up with a smaller velocity because P equals mv. There you go, that should be those first 3 answered.